Well, I have to tell you, I wasn't always sure that I was going to be an engineer. I've always been really fascinated with space, and I actually think it's very human, really. There isn't a culture that we know of that hasn't named the stars that they could see. I lived a lot of my life in London. Forget about seeing stars. But when I did see them, I could not get over it. I've got some family in rural Ohio. We went camping a couple of times. You could literally see by starlight, and I don't think I've ever stopped looking up since then.
Welcome to Tough Tech Today with Mayan and Miller. This is the premier show featuring trailblazers who are building technologies today to solve tomorrow's toughest challenges.
So welcome to Tough Tech Today. We have the honor for this episode of being joined by Ms. Scarlett Koller. She is the CEO of Mithril Technologies. Mithril Technologies is deploying new on-orbit manufacturing techniques with the intention of developing large aperture antennas to monitor weather and storms from space. Welcome, Scarlett. Tell us more. What is this ambitious goal that you have with Mithril Technologies?
Sure, I'm happy to tell you more. Thanks again very much for having me on your podcast. I am an avid listener myself. So really what we're looking at is using this on-orbit manufacturing technique that's been developed in an MIT lab, the Aerospace Materials and Structures Lab, to build large aperture active antennas. And mesh reflectors and large aperture antennas are really critical technologies. Historically, those have been passive, and making them active and being able to build them on orbit gives you the advantage of a way broader range of frequency capabilities. So that's kind of esoteric, but what it means is that we can do Earth observation with this in ways that haven't been possible before, because you can build something on orbit, and that means you can overcome the limits of what you can stuff inside of a payload fairing. Now, already we have a lot of deployable antennas in space, which is great, but even then, there's only so much you can do to fold that up and fit it inside. If we can overcome those launch limits, then we can create very large types of antennas in space. And something that we're looking at as a key application of this tech is doing microwave radiometry from geostationary orbit. And that would have huge value for Earth observation, for real-time weather awareness and forecasting. So already the Earth observation market in the space industry is becoming very important in terms of climate resiliency efforts. It's becoming very important to insurers, for instance, who are really looking to better understand how they can use all of this data to better assess risk in different areas. It's obviously becoming more important for a lot of government operations. And we believe that being able to get better data to begin with is going to be very, very useful to advance this. So what we could do once we're able to make this work and loft it into orbit is get a whole picture of a storm with the whole internal structure. Currently, the best we can do really is look at the top of clouds with optic and infrared frequencies. Or we can get a picture of the structure of a hurricane in a little tiny sliver of it from a low Earth orbit microwave instrument. If we can manage to split the difference, so to speak, do microwave radiometry from geostationary orbit, which currently isn't possible with the antenna technologies that exist, then we can get the whole picture. And that could have huge value. We could get much more precise predictions of, for instance, where a storm is going to make landfall and where it might go on its trajectory. And that already is incredibly valuable. I mean, you only have to look at the kind of destruction that was wreaked by Hurricane Ian, and some of the folks who were in the path and chose not to evacuate just to see the effects.
That sounds incredible in terms of the level of fidelity that this would unlock. Help us understand in terms of, like, we know that, like, every smartphone comes with like a weather app built in. My understanding is it's using things like NASA satellites, so like taxpayer funded big satellites in space that somehow take what they see, and it gets into something that's meaningful for me, like that it's going to rain in 30 minutes. Help us understand sort of the state of the art now, and then where Mithril's going in terms of, this sounds like sort of like an origami approach to making really big antennas.
Right, it is essentially an origami approach. And the current state of the art is actually the summation of a lot of different things. So, as I mentioned, we already have satellites, and many of them, you're correct, are publicly funded, that can do optical and infrared observations from a variety of orbital altitudes, so mostly GEO and LEO. And then we also have low Earth orbit instruments that are in the microwave frequency, as mentioned. And then not all of these are publicly funded, or at least not all of them come right out of government agencies. For instance, Black Sky and Capella are doing a lot of work to make Earth observation data available and more useful. So I think that's very interesting. It's very exciting. But this particular type of technique just hasn't been used yet. And I think it's very exciting because there's currently a lot of realization in the industry that, wow, we have tons and tons of satellite data about the Earth. And it's amazing that a lot of it hasn't even been used up until now. There's a lot of companies that are springing up now that are gathering this data, figuring out how to aggregate it and label it and make it more useful, and even stack together multiple flavors of data, multiple frequencies, so that we can get more interesting, more valuable pictures of Earth. But, I mean, we are still fundamentally limited by the data that is gathered in the first place. And we only have those kinds of sensors that I described, more or less. And, you can do a lot of work with that, and there's great work going on. I don't wish to disparage it. But ultimately, garbage in, garbage out. Not that this data is garbage, just that I believe it's incomplete. So I think this could be a very, very interesting time, because we are seeing a lot of growth in not necessarily hardware-oriented space companies that are trying to gather and aggregate and use a lot of machine learning tools on these data sets. And then we come in a little bit further upstream of that. We would hopefully be able to provide better data to begin with as input. So I think that could be an interesting spot. And given that you have to train your AI on data sets, having better data sets to begin with and not having to always rely too much on synthetic data could be really valuable. And then part of the value of what I've described, as I said, we could have rapid refresh on these pictures of the storms. Part of the limitation of what we have for any microwave instrument in low Earth orbit is that anything in low Earth orbit, you're only going to get what's under the ground track of your satellite. It's usually a fraction of the size of a tropical cyclone. And you're also only going to get 1 to 2 pictures per day, depending on whether that LEO-based instrument passes over that storm. Maybe once, twice a day, just because of the nature of the orbit. If you have something in geostationary orbit, it's always looking at exactly the same part of the Earth. So we could get up to a 1 hertz refresh rate. 1 to 2 pictures, partial pictures per day of the internal structure of a storm just isn't really good enough for the kind of decision making that people need to do when they're in the path of disaster. A 1 hertz update, that's actually a lot more useful.
That's wild. Put that in perspective. That's orders of magnitude. So instead of having maybe 1 partial image per day, we'd get a nearly complete image per second. Is that? Yeah. That's the kind of the range we're looking at. Wow.
It is. And I mean, That said, I do want to say weather forecasting has gotten pretty good with a variety of instruments that are put together, and a lot of forecasting data and a lot of new techniques for extrapolating from that data and predicting. So don't worry, they're not, the weather app on your phone does work, but especially for storms, this is going to be really valuable in making better predictions. Some spaghetti charts for some hurricanes, you can see it sprawls out. I was like, well, if you live anywhere near the Gulf of Mexico, maybe you're going to get hit. I think we can do better than that.
We're getting a lot of afternoon thunderstorms here in the Rocky Mountains, so I could see maybe some better predictions coming from there. One thing I wanted to kind of dive a little deeper for our audience on is you mentioned that kind of the enabling technology is that these antennas can be kind of orders of magnitude larger with in-space kind of assembly and manufacturing. Can you illustrate how much bigger that is? Like what are the size of these antennas?
What we could build that we believe we could achieve at this point is somewhere 30 to 100 meters in diameter. And now I'm not sure about exactly all of the diameters of the reflectors that are in space right now. I think you can go up to about 30 meters in diameter-ish, depending on your deployable. I couldn't speak for everyone that exists, and there are definitely some that I'm not supposed to know about. So we're not looking at a full order of magnitude improvement, at least not immediately, but it is a pretty major step up. We can't really launch anything 100 meters in diameter at this time, but we can if we build it up there.
And where would you say like the technology is at right now? Like how far out until we have these 30 to 100 meter antennas out in space?
So in terms of a timeline, a lot of that depends on my ability to get us enough funding. But what we're looking at, that's true. That's my one job right now. So what we're looking at the moment is a TRL of 2 to 3. There is some environmental testing that is ongoing to see if we can de-risk some of this. So that's on the ground, in lab, environmental testing, and we're hoping to get to TRL 4 to 5, bench models and scalable prototypes in the lab. Obviously, we really do need an on-orbit demonstration here, TRL 7, for it to be viable. And we are anticipating probably 3 to 4, maybe 5 years from now is when we could achieve a full on-orbit demonstration, but that timeline could be accelerated depending on how we're able to secure different types of funding and different types of expertise to contribute to it. So 3 to 4 years, hopefully.
Okay.
Possibly a little bit longer than that. It's not an immediate thing, but it is hard tech. There's really not. This is really not a thing we can manage overnight.
Certainly.
I'm curious with a lot of sort of tough technologies, at least initially, there may have been support from a government agency or sort of maybe some sponsored research from like a well-endowed like corporate partner or something. With Mithril Technologies, looks like it's positioning to be a for-profit entity. Could you walk us through the rationale for pursuing it, constructing the organization as a for-profit rather than, say, trying to somehow get the technology funded and have like NOAA, the National Oceanic and Atmospheric Administration, be able to put up that bird, so to say, put up that satellite and give the data away? Can you talk about some of the rationale around that?
So I mean, in all fairness, the tech has been being developed in an MIT lab, and some of that funding for the research has come from public entities already. Really, what this is a technology transfer startup, and we are anticipating that this is a dual-use technology. Which I'll have to refer your listeners back to your previous episode on dual-use tech because I found it very instructive. This is a dual-use technology. We do think there are government applications naturally for NOAA. There's also some defense applications for protecting various defense seaborne and airborne assets. And then there's obviously commercial applications. And because of that, we do anticipate that the US government is going to be at least one of our customers, and they're likely to be an early stage customer. So, I mean, sure, I guess there's not really a whole lot of reasons that you couldn't just continue to develop this research in an MIT lab and then eventually have NOAA build their own satellite and with this tech and loft it. However, that's likely to take a little bit longer. And it's sometimes very, very difficult for this kind of technology to get out of the lab and really be implemented in the real world. NOAA does amazing work, but it's very likely that they would move a little bit more slowly than a smaller for-profit entity. We have a very strong motivation, naturally, to actually have this work. So it's more of a matter of we can accelerate the process and we can get the thing out of the lab. But this doesn't mean that there isn't public involvement and public investment. As mentioned, the government is likely to be an early customer. And to that end, this is actually, I believe, the philosophy behind the STTR, SBIR programs that are run by different government agencies. They really want to have access to this kind of early stage technology transfer startups that are coming out of major research institutions, and they want to kind of cultivate this spirit of innovation and commercializing new innovative tech that comes out of research labs by offering these types of grants. And so that's some of the funding that we are pursuing right now. I think there's a lot of value in doing that just because I think they can get things out of the lab and into the sky faster.
So how did you stumble upon this technology? Were you part of the lab? Where did you meet your collaborators?
Right. So actually, I was not part of the lab. It so happened that the director of that lab, he and I had crossed paths numerous times. So I did my undergrad in MIT Aeroastro back in the day. I disappeared to work in space for 5 years on the West Coast. And then I ended up coming back for the MIT Leaders in Global Operations program. So I was doing a master's in Aeroastro and then also an MBA at MIT Sloan. And because of that, and because I have a bit of a one-track mind, I ended up as in the leadership of the Sloan Space Industry Club. And in that capacity, I was helping run the New Space Age conference at MIT 2 years in a row. I became kind of re-embedded in the MIT Aeroastro ecosystem, and I knew a lot of people in and out. Now, the co-founder runs the lab. He was not there at the time that I was an undergrad, but we obviously knew a lot of the same people, and he and I connected through a few of those. We got to meet a couple of times at these conferences and varying department events. And specifically what he was looking for, because he knew this tech inside and out, this is developed in his lab, what he was looking for was someone with a technical background, but who was interested in working on commercializing it and had some ideas of how to run a hard tech entrepreneurial business. And I wouldn't necessarily call myself an expert in that, but I was in a position to learn a lot about that, especially with my MBA at Sloan. So we got to know each other, and this is kind of an unusual opportunity to really have someone ask you to join with them on that. And there really isn't a better time to do it than when you're kind of right out of your grad program. So I graduated from that in June, but admittedly I already got started on some things for Mithril before that, and now I'm pursuing that full time.
Awesome. And one last thing on the kind of the founding story I'm kind of curious about is why did you pick the name?
So I picked the name because we're using an on-orbit manufacturing technique called bend forming. And you can almost think of this as making a three-dimensional chain link fence. You have a coil of feedstock that you bend into a shape. And in fact, there's some CNC development in the lab that has resulted in a very cute three-dimensional wireframe bunny, which I absolutely love. And I was making a reference to the chainmail vest that Frodo wears, made of mithril, the precious metal to the elves in Lord of the Rings, because I liked that chainmail reference. I think it's very evocative of the tech itself, and in part it's because teal-backed startups at the moment seem to have cornered the market on fun Tolkien names, and I figured I had to get in there before somebody else names their startup Mithril.
Great plan. Very strategic.
That's the idea.
Yeah, I like it. Something that we. Scarlett, you and I had originally met, in sort of full disclosure, as part of the advisory board member for the Aerospace Innovation Certificate pathway within MIT Aero-Astro. But it's clear your passion for space is deep rooted. Could you, go back to maybe like younger Scarlett and tell us about what is it that, how you mentioned that, like the single track mind kind of thing, like what is it that's been captivating you? Because this is an incredible journey that you're on, and really exciting in terms of what you're starting to build now. Sort of the mens at menace, sort of bringing the mind and hand at play to make this sort of space dream a reality. What is motivating that?
Well, I have to tell you, I wasn't always sure that I was going to be an engineer, and I didn't really know very much about engineering really until I got to MIT for undergrad. But I think I've always been really fascinated with space, and I actually think it's very human. Really, there isn't a culture that we know of that hasn't named the stars that they could see. And when I was a little kid growing up, I lived a lot of my life in London. And at the time that we lived there, the air and light pollution in the city was so bad that the night sky was orange. It was orange. Forget about seeing stars. They don't exist. But when I did see them, I could not get over it. I've got some family in rural Ohio. We went camping a couple of times. You could literally see by starlight, and I don't think I've ever stopped looking up since then. So I think it's very fundamental to be very into space. That said, I know people who are the exception. And for me, I think it's felt very natural that I would make my career in it. It has always sounded a little bit like a pipe dream, but somehow I had a 5-year career in space before I came back to school, and I was able to major in aerospace engineering, and I, in a lot of ways, got very lucky that I was able to do that. I'm a U.S. citizen. It's been easy for me to work in that industry comparatively, and I'm very excited about it. And part of, I think, why this is built on itself is that the space industry is very, very self-selected. Most people are not in this industry purely because they have some other goal or personal gain, although your previous guest, Chad Anderson, did really see a big opportunity there. Most people are in this industry because they're giant space dorks, even folks from all backgrounds, non-technical backgrounds, et cetera, et cetera. And I like that. I enjoy that. If you hang around with people who work in this industry, you tend to learn a lot more about space, and their excitement tends to be pretty infectious. And I think since I wound up in MIT Aeroastro at the age of 18, I think that's been really compelling to me.
You mentioned a couple of times you had a 5-year stint in the aerospace industry. You spent time at JPL and SpaceX. That's quite the resume there. Were there any kind of lessons you learned from those experiences that you think are helping you as you launch off in your entrepreneurial journey?
I would definitely say so. I had a very, very interesting experience at both companies, and I'm really grateful that I got the opportunity to work there. In some ways, again, I think part of it has just influenced me to stay in the industry because I spent time in this industry where everyone there is there because they really want to be there. So I think just by itself, that was huge in kind of shaping the rest of my career direction and my career preferences. And then I definitely learned an enormous amount at both companies. I spent most of my time there as a systems integration and test engineer in a couple of different capacities. And, you really don't learn a whole lot about test engineering and integration at the undergrad level. I got some of that through some of the project teams that I was involved with. Definitely the MIT rocket team was a very useful experience for me, but I really had to learn a lot of the fundamentals behind that on the job. And I think that was hugely valuable in helping me understand, okay, there's the design end, and that's what you spend a lot of time studying in engineering school. And then there's all of that meeting reality, which is integration and test, which is how do you even develop a test bed for something that is going to operate in conditions that do not exist on Earth? How do you convince yourself that you've built the right thing and that you built the thing right when you have to navigate a fundamentally unrealistic test condition? And what do you even need to test? What can you reassure yourself is going to work without having to do that? And I think my 5 years were really just an education in how do you make something that you've designed actually work in this very, very messy, imperfect, real environment. So that was kind of a key thing that I took out of that. And then I do have to say I really appreciate just both at SpaceX and JPL, I worked on some very, very cool, very complex projects that required hundreds, if not thousands of people to work on them for years. And something that I found just absolutely fascinating is you've got a lot of brilliant people, and no one person understands the whole system. It's not possible, it's too complex. And given that, the corollary to that is that everybody has a very different idea of what it is that system does. Right. And that really got me thinking a lot about how is it that, all of these people have a different idea and yet, they're all kind of pulling in the same direction such that your net resultant force is, well, in most cases up. So that's really a people problem, and a lot of systems problems I learned, sometimes the hard way, they're people problems. They're differences in understandings and assumptions and risk stances. And ultimately, I think that's what led me to pursue the LGO program, because it included the MBA, because it really stretched me ultimately in thinking about how people work together and how that affects technical projects. We have an idea that technical projects are cold and emotionless, and they are absolutely not. They are built by squishy humans, and we build all of our squishy human assumptions into them. So, I'm glad that I spent a lot of time kind of learning about moving things into reality and the reality of having human beings develop things. That was really, really valuable to me, and I think it helped me really get the most out of my education. It's part of the reason that, as you mentioned, JMIL, I pursued the Aerospace Innovation Certificate during my grad program.
Something that I think with a lot of folks, and Scott, you and I have mentioned this, and actually the phrasing came through in a prior episode with Chad Anderson of the space informed and the space curious. Could you talk to us on behalf of our readers, listeners, about that distinction and some of and into some of the trends that you're seeing as a young accomplished person in the space of space, and looking to create a business in there? What are some of those sort of macro trends that you're excited about?
Sure. So this came up in your previous episode, which was very interesting. I first heard that particular turn of phrase from Sita Santi, who is director of aerospace at BCG. Might have to correct her title, but it came up in the context of a couple of years. Well, yeah, there was about a 2-year period, maybe 2019 through 2021-ish, where there was a lot of hype about space, and there was a lot of hype about investing in space. And it was a very kind of exciting time to be in the industry. Not that there are dull times in this industry, but it was quite interesting to me because a lot of what I was seeing was that there were a lot of folks who were falling on the space curious side and less on the space informed side. We're very excited about the potential for investing in space and new types of space startups. And in some ways, they were kind of drinking a certain flavor of Kool-Aid. There was kind of a lot of hype around Elon. Not that there shouldn't be, but not everyone necessarily had a full picture of what it was he was doing. And there was just kind of a lot of a lot of money that got poured into a variety of different projects that were, in some cases very, very cool. I never want to tell you that they weren't cool, but things cooled down quite a bit, especially around the time that kind of a lot of SPACs kind of folded. Things cooled down quite a bit because there was sort of a collective realization that around the time that people could no longer afford to invest just vast sums of money into space, unproven space startups, then there was a realization of, oh, okay, well, we don't have the liquidity anymore. So maybe we should really be looking at, is this going to be profitable? Is this going to deliver value for someone on Earth? And very often the answer was no. There were a lot of startups that were kind of creating products for the space industry, and it was very circular. And this is the point at which a lot of investment in space tech has kind of dropped down a little bit. That's kind of the case everywhere. Currently, the fundraising environment is a little bit difficult to navigate. There's just not as much money floating around as there was 2 years ago. That said, I don't think this is necessarily a bad thing. In part, what I believe this diminished access to funds represents is a lot of the folks who got swept up in the hype, the space curious, who found that that when they became a little bit more informed, there were fewer avenues to profitability, and now they're less able to afford really investing in something that isn't going to be that way, and they have left that particular sector. And I don't think that's necessarily a bad thing. I very much want people to be excited about space, and I would love for people to invest in space. But I'm glad that this has been an opportunity where some of the space curious have really become better informed about ways that space can deliver value. And the space informed are now being very, very judicious about the decisions that they're making and the investments that they're making. And that's, I think, a very good thing for entrepreneurs that are coming out now. Because you almost kind of know if someone is getting funding now, then they're very viable. They have real potential. So in some ways, I think that's a good thing. It does mean that it's harder for someone who isn't necessarily a technical person, doesn't necessarily have a background in aerospace engineering, it might make it harder for them to kind of break into that industry just because there's fewer opportunities. But I think it's a good time for them to be really learning about, okay, how does this industry work and how can we really deliver value? I generally think it's a net positive. And it's there's not a lot of this is hard tech as well, so the timelines are going to be long, and the investment is going to not come easy, almost inevitably.
On that note, what's the toughest part about this technology and this business?
This technology and this business, well, they're
two different things, I guess.
They are two different things.
You gotta touch on both.
Right. So I think a key technical difficulty that we're going to face is in GNC, in controls. And so I think it's going to be very, very difficult to come up with a really good system that will be able to control the attitude of the spacecraft while you are changing its center of mass, while you're moving all of this stuff on orbit and building a very large antenna relative to the size of the spacecraft bus.
So during the assembly process? During
the assembly process, I think the controls part is going to be a real challenge. Luckily, power actually is not going to be a huge challenge. We're not going to be power limited, this type of technology, because it doesn't require heating. It's not going to have very large power requirements. But I think controls wise, it's going to be very complex, and I think there's going to need to be a lot of technical development on that. There's currently some de-risking that's ongoing, as mentioned, with the environmental testing. I think that's a hurdle, but it's not necessarily as much of a technical challenge. So understanding how this behaves in a space environment is good. I think the controls are going to be really difficult to master. That said, I do know a few really, really stellar controls engineers, and we'll see how that goes. And then that development is a little bit further down the line, probably not for another year, but it is I think probably going to be a big technical challenge for us. And then in terms of the business, I mean, as I just touched on, we are in a current state of the economy where there's just a little bit less investment in hard tech, and actually getting funding as a startup is just a little tougher than it was even a couple of years ago. This is also, I will freely admit, my first time really getting into raising and really trying to pitch something fundamentally new. So that's a challenge for me personally. And I think that's going to be a challenge business-wise, at least for the next couple of years, because we have to have a pretty solid roadmap of when is this technology going to really graduate the lab, and understanding when that's going to happen is sort of a chicken and egg problem, because it does also rely on funding. But funding is usually contingent on knowing those timelines. So having to juggle a little bit of understanding and a little bit of conjecture there to really come up with an idea of how this is going to go. And again, this is part of why I'm glad that this is a technology that is of public interest, because the entire point of SBIR, STTR is so that the government can afford to take on more risk in terms of small business innovation and technology transfer businesses. So that's an avenue that is valuable to us, but navigating that is challenging as well. And it really does also require the same set of skills that I'm developing right now.
Something that I'm curious about is are your experiences of putting together at the earliest stages what is now known as Mithril Technologies, and up to the present of say pursuing funding and those kind of conversations, because a lot of folks have never, like, say, tried to create a company or fundraise for it. Others, they haven't had the opportunity to, or they've been averse to doing that. So can you take our audience sort of with you and sort of what that experience has been like, the kind of people that you've been engaging with, what's worked, maybe what hasn't worked yet, because I think that could be a really interesting perspective, since you're, again, at the earlier stages and coming out of an academic environment that's pretty conducive to supporting that.
It is very conducive to supporting that, and I mean, I'm not yet in a position to say that something definitively hasn't worked. I can only say it hasn't worked yet. I have been very, very lucky in the sense that I currently am in a position where I can pursue this full time, and I know other people in similar programs who are not in a position to take a massive risk with their career at this particular juncture. I've been lucky in that I am, and it's a good time for me to do something that is possibly a little bit less lucrative for at least a little while. And if it works out, then I fully expect it to be lucrative. But if it doesn't, I do still think, and this is just a kind of general comforting thing to entrepreneurs, it is still a value add, because you do still have this experience of standing up something from scratch, and you have a lot more understanding of what goes into that. And that's it. I mean, I've been learning at a very, very accelerated rate comparing that to previous jobs. I think I've absorbed a lot more information and been able to make a lot more connections a lot faster in this particular role in standing up a new company than I have when I've been joining an existing organization. And I'm very excited about that fact. So if you are considering entrepreneurship, that is huge, and you do not lose that even if things do not go your way. You can, for the rest of your life, say, I actually worked on standing up a new organization to do something technically difficult, and my experience is now going to inform everything else. So I do have to keep reassuring myself of that. I'm learning a lot. Things are this is a value add for me almost no matter what. Mm-hmm. And no, not everyone's going to be able to do that, and unfortunately that's the reality of life. I know other people who would have liked to and can't for a variety of reasons, other commitments, family things, and so on. I've been lucky that I'm in a position where I can do that. And
yet it's still incredibly challenging, and probably maybe in some ways disorienting. At least that's been in my experience. Well, we're high uncertainty, and it's sometimes it can be like, well, there's no boss, which is often viewed as a good thing, but it is also there may not be as much direction then, and that one really needs to manage that uncertainty and start to figure out, well, what is the next step A, B, C, and what to do when that plan gets messed up, and how to be resilient through that.
Right.
And so,
yeah, it's not easy. There is obviously a lot less accountability. It's until you really build out your organization and have a structure, then you yourself as a founder have less accountability. For my part, I think of a few ways that I've been overcoming this, because sometimes I am a little bit paralyzed by just not really knowing if something that I'm doing is the right thing. Something that I do keep reminding myself is that almost anything that I can do in terms of reaching out to folks who are working in relevant fields, on relevant projects, who are people of contact for different government solicitations, anyone that I meet, at the bare minimum, I will learn that that avenue is not one that is of value for me to pursue. That's the bare minimum that could happen. There's almost no downside to just reaching out and asking people, how does this work? And what are your insights? And I think, again, there's huge value in the space industry being very self-selecting, because it means that people very often have very strong networks. I've been able to leverage my own, and I've almost invariably hit into situations where someone will tell me, I don't know about this, but I know 5 other people who do. So leveraging your network, almost any contact you can make is going to be a net positive, because at the bare minimum, you're going to find out, this is not a relevant path of inquiry. So, I have to keep reminding myself, it doesn't matter if not everything that you learn and that you advance your work on, and not every contact is going to be a potential customer. It doesn't matter if this next person you talk to isn't. It matters that you've tried and that you keep expanding that, because that is the only way you figure out where your business has the opportunities. And then that I am nervous about this. I very much am. This is not an easy thing to do, and I do have to do more self-promotion than I'm used to. But I've been somewhat heartened by meeting a lot of other people who are in a similar setting, a lot of folks who have come out of this MBA program with me, who are pursuing all sorts of entrepreneurial ventures. And I think it's very advisable, if even, you don't have to be in a grad program to do this, but if you want to pursue any kind of entrepreneurship journey, definitely try to meet other people who are engaged in something similar, who are trying to get a new piece of technology off the ground, or change the way that people, for instance, do 401k investing. I know someone who's working on that right now, because they tend to be incredibly optimistic, obviously, or they wouldn't be doing what they're doing. And like the passion for space, that kind of energy is very infectious. I've found that really valuable, because sometimes I struggle and I'm very nervous about what it is that I'm doing. And I found that it's very confidence building to speak with some of my friends that I know are working on their own ventures in various capacities, and really absorb how excited they are about what they're doing and about their interest in learning about what I'm working on. They have confidence that I will succeed, which is stunning to me, but I have a lot of confidence that they will, because I consider them to be brilliant people. So that's been very, very valuable to me. And just having that network of people who are in a similar stage and doing similar things in their careers.
Scarlett, I have a lot of confidence that you're going to succeed. So I've seen you do it time and time again. At this point in the episode, at this point in the episode, we like to give you an opportunity to kind of make a pitch to our audience. If you're looking to hire, looking for collaborations, if you have some sort of ask, feel free to reach out and let our listeners know what you'd like to let them know.
Even if you need to tell your friends that your head's down building stuff, and it's sorry that you're not responding to text messages and Hangouts.
There's a way to get the message out.
Yeah.
Well, in all fairness, I'm lucky. A lot of my friends are in the same industry or otherwise involved in ventures, so it is actually not too bad. Sometimes I've been leveraging that. But if I had a call to action right now, it would be mostly about information and understanding, because we are really trying to get a much clearer picture here of the scope of our opportunity. If you are currently working in any kind of weather awareness, or in any kind of large aperture antenna tech and its various applications, whether in the government or in the commercial sector, I would be very, very interested in hearing from you. especially if you think you have a new commercial application of this type of tech. We're already talking to folks in insurance and possibly in aviation and definitely in defense on uses for our technology. And if you have any thoughts on that, anyone that you think would be interesting for us to talk to, then please reach out. I would be so interested to meet and speak with you. So I can be reached at Scarlett, and that's Scarlett with 2 T's, at mithril.space. So that would be where to reach me for that. And I really would love to get to know a little bit more about anything that anyone knows that they think could be useful. This is a learning experience for me and for my co-founder. So it's a lot of fun. I would definitely appreciate more learning opportunities.
All right, everyone, send in those messages.
Yeah, thank you. It's been really fun talking to both of you, and I'm very, very flattered that you invited me to be on the podcast. I've already listened to the first part of the 3-part series, and I'm very excited to hear the third one as well.
Thank you very much for joining us. We really appreciate having you on the podcast today.
I'm Scarlett Koller, the CEO of Mithril Technologies. Stay tough.
Though complex and fraught with challenges, the allure of space and its relationship to our planet inspires and drives tough tech trailblazers like Miss Scarlett Koller. To finish our 3-part series on space, our next guest is Preston Dunlap, the first Chief Technology Officer and Chief Architect of the U.S. Space Force and Air Force, and founder of Archistone Ventures. Until next time, stay tough.